Hello, welcome back. We are here to continue solving our model exam for grade 12 mathematics. The first question for today, let f of x equal to absolute value of x times x square. Then f second derivative at -3 equals, it says. So first of all, let us try to write the given function appropriately. F of x is the same as absolute value of x will be either x or negative x. So when you take out as x as it is, when x greater or equal to 0, so x times x squared will be x cubed, and the other outcome will be negative x, so it's going to be negative x cubed. So we have two outcomes, x cubed or negative x cubed. This is the function f of x when x greater or equal to 0 and when x is less than 0. Now derivative it. The first derivative of x, it will be 3x square and negative 3x square. You are going to derive each of them. And the second derivative, again the same manner, it's going to be, you are going to derive each of them. So it will be 6x or negative 6x. So each of them for x greater or equal to 0 and for x less than 0 here. Here also, x greater or equal to 0 and x less than 0. Now we are going to focus on the last part here because we are asked the second derivative at -3. So when we are talking about f second derivative at -3, which function will be taken, the first one or the second one? -3 is found under the interval x greater than 0 or x less than 0. You have to be focused here. It must be x less than 0 because -3 is found here. So that I'm going to take this function. So it will be -6 times -3, which is going to be 18. So the answer will be B. Okay, let us continue the next question. The next question, it says, if f of 3 equal to 2 and f derivative at 3 -1 and g of 2 is 3 and g derivative at 2 1. These are all given condition. And the main question is after that, here it is, g of x is equal to this one. Okay, our game will be here. And then it says what is g derivative at 1. We are talking about the capital G, capital letter G. So first of all, we have to derive this function. This function is product of two functions, as you see again. There are two functions. What and what? F of something times g of something. Even that something is a function for each. So chain rule will be applied here. So first let's derive g of x now. G derivative of x means I'm going to apply product rule. This one times this one. So what to do? Let me try to show you by different color. The first function I can color it by yellow and the second one by green. Now product rule says the yellow derivative times the green one as it is plus then the green derivative times the yellow one. Okay, you can take it in that manner for the first derivative time. So what the derivative of f? F derivative will be, f derivative of what? X squared plus 2x. First of all, the outer derivative of it times by chain rule, still I'm on f. I'm deriving f derivative, here it is, times, let me finish f, the inner derivative. What is the derivative of the inner function here? X squared derivative, it's 2x. And let me write it by another color here, better to make it clear. 2x plus 2. This green one, it is the outcome of still the f derivative part of it. Because the derivative of the inner part, here it is. First f derivative, here it is. And then the inner derivative, then times, okay, this is all about the first derivative times the second as it is. G of 2x. Better to make it the same, g of 2x plus now when I go to the next one, the first as it is, I'll take it, f of x squared plus 2x will be taken as it is times the second derivative, that means g derivative of 2x times the inner derivative of it, which is 2. Now I'm going to substitute 1, g derivative at 1. That means we are going to insert just 1 in place of every x. It's going to be f derivative of, when you insert 1 plus 2 will be just 3 times again 2 plus 2, because in place of 1, when you insert 1, 2 plus 2 will be 4, times g of again 2 plus, again insert here, f of 3 times g of 2 times 2. This is g of. Therefore, g derivative at 1 will be f derivative at 3. Is that given? Yes. F derivative at 3, it's here, -1. So, -1 times 4 times, what about g of 2? G of 2 also given to you, here it is, that is 3 plus, and f of 3, it is 2, here it is, 2 times, again g of 2, g of 2 also it's 3, times 2. No, this must be g derivative at 3, because this one is derivative, the second part. So g derivative at 2 will be, g derivative at 2, it's 1. I'm going to take 1. Then when you multiply, negative times 4 times 3, 12, times -1 will be -12 plus, here it is 4. When you add it, it will be -8. So the answer will be C. So this kind of question you need to take care. Even if it's product, chain rule, okay? Two properties will be used. Two rules. Those rules are product rule and chain rule. Let us continue to the next one. Okay, the next question, it says, which one of the following is not true about the function f of x equal to 4x cubed minus 6x squared minus 9x? This function, it's talking the choice, look. Choice A, decreasing and increasing intervals. Choice B, maximum and local maximum and local minimum value at which point. And choice C and choice D, they are talking about concavity and inflection point. That means we are going to derive, we need to derive the given function once, and then we have to construct sign chart, and we have to see the positive and the negative intervals. What do I mean? First derivative of the function less than 0 intervals are decreasing, and first derivative greater than 0 intervals are increasing. Remember those rules. And to find decreasing and increasing intervals, we have to derive and factorize, and we have to observe the sign. The sign, where is positive and where is negative, like constructing sign chart. It will be somehow longer process. And decreasing and increasing also the same. And to find the maximum and the minimum, we have to see sign change. For example, from positive to negative means, it's maximum, and from negative to positive will be, it's going to be minimum value, and maximum value will be found at those points. And to discuss about concavity, we have to take second derivative again. Second derivative less than 0 is concave down, and second derivative greater than 0 will be concave up. This one is down, and this one will be up. And change of concavity will be inflection point. So this question, it will be somehow longer, but you need to be fast. It says not true. So let us to derive and let us see the process. So when we try to derive the function, let us derive it together. F derivative of x will be, it is 12x squared minus 12x minus 9. Then let us factorize. First of all, take out 3 common, then 4x squared minus 4x minus 3. Then think of two number, product -3 and sum -4. Product -12, because A times C, 4 times -3, -12, and sum those numbers obviously will be -6 and 2. So let us insert them here. It's going to be 3 in bracket 4x squared plus 2x minus 6x minus 3. You have to be faster, as I said before, and take out 2x common here, group them and take out common. What is common here? 2x. Then what left? 2x plus 1. What's common here? -3x. Then what left? 2x plus 1 remain. Then the complete factorization will be 2x plus 1 times 2x minus 3. this is the first derivative, imagine. And there is a coefficient number 3. It doesn't affect actually, but you can write it, the coefficient 3, because our objective is to observe where is positive and where is negative of this interval, I mean this function. Okay, let us go to the next page. And then we had 2x plus 1 and 3x minus 2. That means where does this will be 0? At x is equal to negative 1 over 2, you know. This is going to be 0 at 2 over 3. Therefore, construct a number line and plot these numbers. The smaller one is negative 1 over 2. You can plot it somewhere around here. And the larger one is 3 over 2. This is 2x minus 3. That means 3 over 2. Therefore, what are the functions? 2x plus 1 and 3x, this must be 2x minus 3, so that 2x minus 3. Yeah, here it is, 2x minus 3. Therefore, our sign chart will be here it is. And let us see now. This 2x plus 1 will be 0 here at just 1 over 2. At this point it will be 0 and less than negative, and greater than it will be positive, you know. If you take any number greater than 1 over 2, for example, insert 0 here, it will be positive. And 3 over 2 will be 0, 2x minus 3 will be 0 here, and less than negative, greater than positive, because the coefficient of x, if it is not negative, always below negative and above positive. Then try to see the interval. Negative times negative will be positive, and here it is negative, here will be positive. Now positive intervals are increasing, as you said, so that means this interval is increasing, here also it's increasing, this one is decreasing. So what is the decreasing interval? Between negative 1 over 2 and 3 over 2. Let us see the choice. It says choice A, it is decreasing between these two intervals. Yes, that's correct. And increasing on the other interval from negative infinity until negative 1 over 2. We said it already, because this interval means from negative infinity until negative 1 over 2, again from 3 over 2 until infinity, because this is a number line, don't forget, this is a number line, it continues both sides. So choice A, it is correct. What about the maximum and the minimum? Try to see the sign change, as I said. This one from positive to negative, it changed. The sign change here from positive to negative, so that this is maximum. And here the sign change from negative to positive, as you see, so here will be minimum. So maximum at negative 1 over 2 and minimum at 3 over 2. So let us see the choice. It says maximum at 3 over 2, wrong. We said maximum at what? At negative 1 over 2, but it says at 3 over 2, so wrong. This is wrong, the answer must be B. The other one, concave up and concave down, you have to derive for the second time again. When you derive second time, for example, look, second derivative will be this one will be derived again. When you derive it will be what? 24x minus 12. So this will be 0 when x is equal to what? 1 over 2. So this means the inflection point. So the inflection point is at 1 over 2, that's correct. And this function below 1 over 2, it's negative, so concave down from negative infinity until 1 over 2, that's correct. And above 1 over 2 it will be positive, that means it's concave up, so the answer obviously will be B. Somehow time taking and longer process. It's not hard, but longer process, because it is containing all the concept of those the application of derivative, first derivative and second derivative. It's containing all, that's why. Let's continue the next question. The next question, it says, what is the polar form of 2 plus 2i? First of all, to find the polar form, to change into polar form, we need to find r and theta. R means the modulus, that means 2 square plus 2 square, which is 4 plus 4, 8. 8 means, you know, it is 2 radical 2, that is r. Which one contains 2 radical 2? The r, as you see, A and D. So we are minimizing, even we are approaching to the answer. Now theta is equal to tan inverse of, you need to make it y over x. The y over x means the x is the first one and the y is the second. That means tan inverse of 2 over 2 means just 1. 1 degree, 1 tan inverse, or tan of how many degree will give you 1? It's 45 degree. 45 degree, or you can say in radian measure pi over 4. Therefore, the polar form of this complex number z will be 2 root 2 in bracket cosine of pi over 4 plus I sine pi over 4. So the answer will be D. Let us continue. The next question: what is the absolute maximum value of x square minus x cube on the given interval? Okay, the function f of x is equal to x square minus x cube, and intervals, the interval is given to you. So how to find absolute maximum and absolute minimum value of a function in the given interval? What to do? First, derivatives like I did before, and then find the zeros. So the 0 points and the end points of the interval will be critical numbers. So you are going to evaluate the function at each critical numbers and try to observe which one is larger and which one is smaller. So the process: first, let's derivate. What's the derivative of the function? Is application of derivative. When you derivate it, it will be 2x minus 3x square, and then factorize and find the zeros and make it equal to 0 and find the critical numbers. So what's common here? X. So 2x minus, 2 minus 3x remain. I just take out x common. So let me change the color to make it somehow clear. X, when you take out, what left? 2 minus 3x is equal to 0. Then the product 0 means x is equal to 0, or 2 minus 3x is equal to 0. Therefore, when you reshuffle and solve, the x value will be what? 2 over 3. At this point, what are the critical numbers? The critical numbers, first the interval point, negative 1 over 2, and then 0, and then 2 over 3, and then 3 over 2. All of them are critical numbers, not only the 0 points of the derivative. The derivative 0 points, we got them already. What are they? X is equal to 0 and x is equal to 2 over 3. This is obviously critical numbers. Not only derivative 0 point, even if there are undefined point of the derivative, those numbers will be taken as critical numbers. And in addition to that, we have to take the intervals, okay, the boundary numbers. Therefore, all these are critical numbers. Therefore, we are going to insert each number in place of x in the original function, and then we are going to compare. Let us do that. So what is the function? F of x is equal to x square minus x cube, and the critical numbers, we said negative 1 over 2, 0, 2 over 3, and 3 over 2. These are the critical numbers. So what is f of negative 1 over 2? That means negative 1 over 2 square minus negative 1 over 2 cube, which will be 1 over 4 minus will be plus, because cube, when you cube it, it will be negative remain, so plus 1 over 8. When you add it, multiply by 2 to make the denominator the same. 2 plus 1 will be 3 over 8. This will be the first answer. Again, f of 0, if you insert 0, it will be obviously 0. And then the next one, f of 2 over 3, insert 2 over 3. When you insert 2 over 3, it will be 4 over 9, minus, when you insert 2 over 3 here, it's going to be 8 over 27. Then when you subtract, multiply by 3, because to make the denominator the same, 12 minus 8 will be 4 over 8. Again, f of 3 over 2, when you insert 3 over 2, it will be 9 over 4, minus, again, when you insert 3 over 2, it will be 27 over 8. Multiply by 2, 18, so it will be negative 9 over 8. Okay, now look the outcome. Here is the first outcome, here is the second outcome, here is the third one, and here is the fourth one. But we need to correct here one thing. This one, the denominators are 27 and 9, so I multiply by 3. 12 minus 8 is 4. 4 over 27, it must be 27. So which one is the smaller number? Obviously, the smaller one is a negative. This is a minimum. absolute minimum value. What about the maximum? The maximum are either of the two positive numbers, but which one is larger, 3 over 8 or 4 over 27? Obviously it will be 3 over 8. This is absolute maximum value of the given function. So the answer must be C. Remember everyone, what do I do here? We are asked maximum, absolute maximum. So first I derive and just I make it 0 and I try to find the zeros. Also the 0 points of the derivatives are critical numbers, including the interval numbers, like the end points of the intervals. And then the next step, I just substitute every critical numbers in place of x, and then we calculate. From this we are going to compare which one is the maximum, the largest one, and which one is the smallest one. The largest will be the absolute maximum and the smallest will be the absolute minimum. That's the way how to do, and I will get back to you with another video. Don't forget to subscribe and like and share to your friends. Thank you for watching.